This is topic 5.8, sketching graphs of derivatives. And we're going to begin with focusing on the slope of a function. And the slope of f of x is the y value of f prime of x. So we have two different cases here. We're going to be sketching f prime given the graph of f. And in the next one, we're going to sketch f, and we're going to be given the graph of f prime. So there's f prime, and there's f, okay? I'm going to kind of zoom in a little bit on each one of these. So what I want to talk about here is, can you see on the graph of f that all of these slopes of these tangent lines are positive, except what happens? They're getting less and less and less positive, and all of a sudden the first derivative is going to be equal to 0. So we are actually going to plot this 0 here, and what we're going to do is have the value of the slope placed on the graph. So we said it was just a little bit positive there, so I'll put a point there. And then at this x value, it's a little bit more positive, and at this x value, it's a little bit more positive. And as you can see, our graph of f prime looks something like that. So these are the y values. This slope is very large, and so is this number. This slope is positive, but it's not as positive. So those are the y values that go there. Okay, what happens here? This is pretty interesting from here to here. This is another place where the first derivative is equal to 0, so I know that the first derivative y value is 0 there. But notice this. When you have this slope of this tangent line, it is negative, but it's just a little negative. And when you're here, it's negative, but it's just a little bit more negative. But then when you get here, this is the most negative that the slope of the tangent line ever gets, because here it's still negative, but it begins to turn around until it gets to 0. So that is why this graph of f prime looks like that. And let me give that one more try. Okay, so what happens to the right here? What do you notice? These tangent lines are positive, but they're getting very, very positive there. So the y value, you could say right here, would be very high, and then the y value at this point, well, it's just not as high. It might be there. And then you can see where this graph of f prime looks something like that, okay? So now let's label that f prime of x, okay? So that's how that does. Now, I do want to mention that going the other way can be a little bit more difficult, okay? What we have to keep in mind is that f prime is the slope of the tangent line to f. So the slope of f is f prime's y value, and that's what all of these are. So the y value here, right here, that is going to be where the first derivative is 0. And the first derivative is 0 here, and the first derivative is 0 here. Now the first derivative is negative here and positive here, so why don't we make a sign chart? So if we have f prime sign chart, and we just put these x values right there, where the first derivative is 0. Now, let's go in between these zeros. Our first derivative all have negative values there. In between these 2 points, positive, negative, and positive. So what do we have here? We actually have a minimum here, a maximum here, and a minimum here. So it's very interesting. So that's going to help us make this graph of f of x. So if I have a minimum here, maybe I could just do something like that. Maybe I could make that a little bit lower. So if I have a minimum, maybe I might draw it like right there. And then if I have a maximum at that x value, I'm going to just draw it there. And a minimum here, I might draw it right about there, okay? So now we're going to connect this, try to sketch this graph knowing the values of f prime. So if the derivative is negative here to the left, that means that this function is decreasing on that interval. And then, if you notice here, this graph is going to come around. This is the most positive. So right at that x value is when the graph changes concavity. See if I can draw that kind of like that, okay? And maybe that last one needs to come around a little bit more, okay? And so what we have here is where the derivative here changes from increasing to decreasing right here, and changes from increasing to decreasing here. So these are going to be points of inflection, not that actual point, but here is a point of inflection. And whoops, how do I put that back? And we have a point of inflection right here. So that is why I was trying to get this graph to change concavity about right there. And it can actually happen at the 0 if you want. And we want the same thing to happen here to change concavity. And then, of course, we are increasing the rest of the way. So the graph that I just drew was f of x. Let's see if this makes sense. This is where the second derivative is equal to 0. That's where we change from concave up to concave down. You see, the second derivative is 0. And the second derivative is 0 here, and that's where concavity changes. I think this f prime chart helps. So I want to show you how you can put f and f prime in the calculator. So bringing the calculator up, as you can see, I put a quartic in y1, and that is blue. And the derivative of y1, I put in y2, and that is red. And that gives us this graph right here. And you don't have this in your notes. I just wanted to show you the difference. So on our blue graph, this is f of x, and our red graph, this is f prime of x. So let's see if this makes sense. The first derivative should be 0 here, and sure enough, what do we have? We have the first derivative value is 0. Let's go backwards. If the first derivative's value is here, then we should have a slope of a tangent line of 0 here. And let's look at here. Slope of the tangent line is 0, and we have f prime of x plotted as 0. F of x is increasing here all the way, and so f prime of x is always positive. F prime of x, we are decreasing here, and so that is why we have all of these negative values of f prime. So I hope that helps, and this concludes the topic.